Hello and welcome back. Today we are going to discuss the Silurian Hypothesis based on a request from one of the patrons. So let's talk about it. To keep it very simple, the Silurian Hypothesis is not a statement that in the past that there has been an advanced civilization on Earth, but is a scientific thought experiment that asks,
if there has been an industrial civilization millions of years before us, would it be able to detect it today?
For the scientists behind the article, Schmidt and Frank, is the hypothesis about the detection problem. It's not about existence. The main problem, or should we say the main thesis in the hypothesis, is that an industrial civilization is one that uses energy in large scale as we do today. So the question Smith and Frank raised is what traces will civilization leave in the geology, and will these traces survive millions of years? Adam Frank says in an interview, "We did not say that there was a civilization. We asked, how would we know?" The hypothesis has a key problem. That is that the surface of the Earth is reset. Tectonic is reusing the Earth over millions of years. Everything older than a few million years is often melted, buried deep, or is eroded away. So that means that what we have today in some forms of cities, of roads, and artifacts, etc., will not survive. Furthermore, it's only a fraction of the organism that's actually going to be fossilized. So that means if we look at dinosaurs who lived for millions of years, we only have a few found. I think it's about 1,500 species that we have found. The rest is gone. So that means that a civilization that lasted, 10,000, 20,000, perhaps 100,000 years will probably not leave any kind of fossils. So the hypothesis have a theory, that is that we should look for indirect geological fingerprints. So if we look in our own time, we will ask, what do we leave? And that is chemical signatures. That could be changes in carbon dioxide. It could be disturbances in sediments, etc. Also, the climate has some issues here. We are discussing fast global heating. We are discussing changes in oxygen, in temperature, and in the chemistry of the oceans. So the assumption is that an industrial civilization will almost certainly change the climate. Furthermore, we have pollution in terms of heavy metal, be it plastic, artificial chemicals, radioactive isotopes, etc. These kind of things can survive very long time in terms of geological things. Furthermore, we have changes in the biosphere. We have mass extinctions. We have sudden spreading of certain species, and so on. But the thing is with this, that is common nature things, they can actually do the same signals. For instance, if a volcano erupts, we have meteors impact, or we have natural climate changes. So even if we see a temperature rise, we see changes in the isotopic things, and we see changes in the biosphere, it can still be absolutely normal. So what does it actually say? What is the contribution of this hypothesis? It's important because it actually sets our own civilization in perspective, because our fingerprint might be only a few centimeters thick in terms of geology. But it helps astrobiology, because if we are looking for life on other planets, perhaps we should know what kind of traces that we are leaving. And it also raised some questions, because how often is technological civilization actually occur? And how long time do they last? So if we look in our own past, we actually see something. And here I apologize in front of my pronunciations of these things. But the first and most important thing is the Paleocene-Eocene thermal maximum, called PETM, and that was about 56 million years ago. At that time, we have a rapid rise in the temperature between 5 and 8 degrees Celsius. We have a large rise in the carbon dioxide in the atmosphere. And then we have a rapid change in the isotopes related to the carbon dioxide. So why does it look like a civilization signature? The thing is that when we have a rise in the carbon dioxide, we have a climate shock, we have changes in the ocean chemistry, then it's exactly the type of signal that industrial civilization would leave. But the thing is that if you look at it, that is the timeline. It's slower than our current heating of the global heating. And the most likely reasons is actually volcanoes and the release of methane from the ocean floor. So the point here is that even that we have something that looks like us, it could be entirely natural. If we look at the 120 million years ago, we have the ocean anoxic event called OAE. And what happened was basically that the oceans was losing oxygen. So large areas of the ocean become dead zones. We have black organic sediments that was created as sediment. If we ask ourselves, how does that look like something that created by humans? Because today we are creating dead zones, and that is primarily due to pollution, of course, but also because of farming. So bottom line is that we have the same mechanism as, should we say, modern environmental effects. But yet again, we can have a natural explanation that could be volcans erupting. It could be changes in the circulation in the oceans. Furthermore, we also have mass extinctions. For instance, for 66 million years ago, we had a very certain, a very substantial fall in biodiversity, basically mass extinction. And we have a very thin layer in the geology with unusual chemistry, for instance, iridium. It's relevant because an industrial civilization could also extinct species, but it could also change the ecosystems dramatically. And to be bluntly, if we look around, we are doing exactly the same. But it could also be because of a meteor impact. It could be because of supervolcanoes and things like that. So the point in the Silurian hypothesis is that we can find layers in with sediment where we can see that there are changes in the climate, we can see chemistry anomalies, and we can see changes in the biosphere. but we cannot say if it's natural or technological. But the thing is that the hypothesis is actually having a quite wild conclusion. And that is that even if an advanced civilization has existed, say, 100 million years ago, it's not certain that we could prove it today. Not because it does not exist, but because our methods has limitations. So when scientists today is comparing our, should we say, current fingerprints with previous geological events, some events like PETM, OAE, or mass extinctions, they look very much like what we are doing today, but they could all have natural explanations. And that shows, that is why the hypothesis shows how hard it is to separate technology from natural explanations. So if I sum up, one of the key problems is that the Earth is resetting its own history. In the same way as if you take a USB drive, put it in a computer, and then do formatting. So, because of plate tectonic, because of erosion, because of other kinds of degradation, over millions of years will all physical remains of a civilization simply be destroyed. Cities will be eroded, metal, concrete, etc. will all be gone. Artifacts, everything will be gone. So that means that we cannot find direct traces. We need to look for indirect traces. We need to look for fingerprints. We need to look in the geochemistry tracks, if you say so. We have to look for isotopic changes. We have to look for changes in carbon dioxide. And we have to look after artificial, or should we say rare minerals. So if you say something like, on this basis, you could argue that we do not know if an advanced civilization has existed before. The short answer is that that is not entirely true. I mean, it's wrong to say we do not know it, because should we say the correct answer is a little more complicated. We could say, on basis of this theory, that we have no proof that for previous industrial civilizations, but on the other hand, we cannot rule out it with absolute certainty. If we look for Frank and Smith, they do not rule out with certainty that no civilization has existed in the past, but they say something like that we have no fossils, we have no artifacts, we have no geochemistry signals. So that means that they have strong doubts that previous civilizations has existed, but they cannot rule it out with certainty. According to science, Homo sapiens has existed for about 300,000 years, and the Earth is about 4.5 billion years. And since no land is older than, say, 150, perhaps 200 million years, then we have a lot of, should we say, aids to explain. If you look at the ocean floor, that is typical less than 200 million years old. And if you look at the surface of the Earth, then it's constantly changed and, should we say, reset. A centimeter, or perhaps half a centimeter a year, might not sound as much. But if we take millions of years, then the entire surface of the Earth is reused. And that means that in reality, it's we cannot use it as an archive. Because what we have today will probably, in millions of years, say 50 or 100 million years, it will probably be bottom of the ocean or something like that. And that is actually quite important, because that means that if we have to look, say, 50 million years back, 100 million years back, we don't should look at the surface. We should look at the bottom of the surface. But not only that, because it might be below the ocean floor. So if we look at the 4.5 billion years, then the first 500 million years, then Earth is created. There was probably heavy volcanoes and meteor impact and so on. And there was probably no stable surface. There was no life. That was very chaotic. So for the first 3 billion years, then we have life starts, but it's only be a simple organism. It will be bacteria and so on. If you look at the, should we say, more complex life, then we look probably at the last 600 million years, where we can see that animals is developing and we see plants on land and so on. If we look at the dinosaur area, that is about 230 million years until 66 million years ago, where we have this meteor impact. There we have complex animals, we see millions of years with evolution, and we see no technology. So you could ask, why is there no civilization in this? If we go further from 66 million years until today, then we see, after the extinction of the dinosaurs, we can see mammals is developing, and eventually that Homo sapiens is developing. And if you look at Homo sapiens, that is for the past 300,000 years. And if we look at the farming, we are discussing the past 10,000 years. And if we are discussing industrial scale, it's for the past 200, perhaps 300 years. So what we call civilization is actually a very tiny fraction of 4.5 billion years. If we are discussing industrial, 300 years versus 4.5 billion years, that is a very tiny fraction. It's like, if you look at an hour, it's not only a second. So, but if we look at that, it's so much time. So I think that the question is it possible that inside, say, the last 100 million years, that a civilization could have been created and disappeared again? And here I'm only talking about the last 100 million years, not about the 4.4 billion years that goes before that. If you ask a scientist, he will probably say that this is a rare coincidence when the human has developed this industrial scale civilization. My question is that if it happened once, why not multiple times during 4.5 billion years? I think it's actually absurd that there should be no more, should we say, tries. But the science will say something like that a technological civilization would require an extreme combination of intelligence, of hands with the, it will require language, it will require culture, it will require access to energy and stable environments. So it's not just a matter of intelligence, it's a very specific package. And furthermore, an important point here is that they would say that timing is actually crucial, because we are living at a time on Earth where we have fossil fuel, we have a stable climate, and we have, should we say, a high degree of biodiversity. And it's not certain that all these factors has been available in the past. So they will say something like that, even if you have the time, that is not the same as development of an industrial civilization has happened several times. If we look back at my argument, and we're only looking at the last 100 million years, that is, I would say, quite some time. And if we look at 300,000 years, which is for the development of the Homo sapiens, that is only not even 3%, it's 0.3% of 100 million years. So in reality, I would say that in the past, it is possible for the past 100 million years that all the factors required for development of not only life, but also for the factors for an industrial civilization, they could be created and they could be lost simply because we cannot detect them. We have seen that surfaces is changed, that sediments is buried, and ocean floor is reused, it is reset. So after millions of years, cities are gone, artifacts are gone, and very few fossils are actually existing. One of the key things is here, scientists would argue against they would say industrial civilizations, they will leave global traces. If a civilization reach our level, it will change carbon dioxide, it will change climate, it will change different things, and it will spread metals and chemicals. And that will happen on the entire planet, not only local. Here I would say something like, you don't know that for certain, because technology can be different. You assume that what you're looking for is our technology and not something else. And I will return to this argument later on. So the point is, if you ask me, is that we will see traces, but we cannot know for certain if it was a civilization. And because of that, we cannot rule it out. It could have happened, and it could be gone without traces. That is my point. You could put it down to like these two phrases. It's not that we will not see it. It is what we see that we might not be able to recognize it. And one of the key things is here that if something is supposed to be natural, then it can always explain something technological, because the assumption is that it's natural, and that's why we will always return to that. So that means that even if we find something technological in the past, we can always explain it that this is pure natural, and then the hypothesis about previous civilization is impossible to confirm. In science theory, this is a problem with that is not possible to prove this. So if you have same, should we say, signal in the geology, but you have multiple explanations, then I do agree that the nature can mimic technology. But the thing is that if you have multiple explanations, it might be, should we say, not the correct answer that you choose, just because it's the easy one. And that is actually one of the key problems, if you ask me about science, because they always go with the simple explanation. The simple explanation is natural, it's well documented, and civilizations before us, no, we have no evidence of that. So let's go with the simple solution. It's not enough something can't be true, it has to be even more true. So the key problem here is actually that the Silurian hypothesis is not just about the past. It's about how do we know something at all. So let me take an example. The Oklo reactor in Africa. That is an area in Gabon, the country Gabon in Africa, that is for about 2 billion years ago. Then there's happening, how should we say, a self-sustaining nuclear reactor. So, in my view, it sounds like something that is being built by somebody. Because an atomic reactor to work, it requires urine, it requires a moderator, in this case water, and then it requires certain circumstances. So when we design nowadays in an atomic power plant, then we do the same, should we say, design criteria. So, but science says this is natural. So that means that for thousands of years in Gabon, you had water that goes in, then it heats up, vaporize, and then the reactor restart. And that happens for thousands of years in a stable process. So that means that, to put it bluntly, that the urane was about 3% in, should we say, purity, whereas today it's about 0.7%. So that means it was much higher at that time, for 2 billion years ago. And that is actually the reason why science says that this is natural, because it could happen natural. And the geology was actually perfect, because the urine was in layers where the water could pass. So when the water passes through, it works as a moderator, and if it becomes too hot, then the water will vaporize and the reaction will stop. And then it will turn on and off automatically with the water flow. And the thing is that if you look at the isotopic signature, that is precisely as natural fission. So that matches the reaction, and the science says actually that this is not created by humans. It is not something that looks like, it's purely natural. And we can explain what happened. It's not unnatural, but it requires a rare combination of uranium-235. It requires a certain geological structure, and it requires water flow. It's extremely rare, but it's not mythical, they will say. My point here is that if something is natural, perhaps we should see it elsewhere. Listeners of this channel know that I'm a big fan of Darwin. And actually Darwin, he was actually very scientific. In his theory, Survival of the Fittest, he was asking himself the crucial question. He said, if I am right and the survival of the fittest is a correct theory, where is all the losers? And that was actually his key problem. He says, where is the losers? And that is exactly my point here. If this is natural, we should find this concept elsewhere in the world. It might not become a full-blown reactor, but we should find something. A part of being, should we say, a natural explanation is also that you actually see it more than once. And furthermore, if we assume that science is right, this is natural, then it looks exactly like technology. How would we know the difference? Personally, I think that the Oklo reactor is actually a quite extreme statement. Because if an atomic reactor is actually created natural and it can run for thousands of years, I think that requires an extraordinary proof. It's not enough to say that because we can explain the physics, then it's natural. You should see tracks of other atomic reactors. I mean, if you look at where you have urine around the world, then it's not uncommon that it's found in mountain areas. It's not uncommon that there's water. Something here should happen. And if you go back in time, 2 billion years in this case, then you have a much higher enrichment of the urine. But also because of that, that should lead to more, should we say, failed reactors. And where are they? And simply because, and that is my point, because we only have one reactor, you should provide an extraordinary case for this. So my bottom line here is actually that proves that science is not objective, at least not 100%, because bottom line is that this is a subject judgment. So if two scientists look at the same data and we can see the same results, then they basically can choose different explanations. And if you have a scientific explanation that says this is natural, then it becomes, the default explanation. So why, talk about atomic reactors when we can say that we know what happens because of this? But what you explain is actually what is happening. You do not explain how it is created. To put it bluntly, if you say this was technology, then you suddenly have to explain, who created it? It has to be an unknown civilization. There has to be, some kind of mining. It has to be, who designed the reactor and these kind of things. I realize that is a heavy explanation. So it's a lot easier to say, this is natural. We know the principles and so on. So I don't want to discuss it's artificial. We simply just say that this is natural. So then you suddenly will say something like that just because it's rare is not the same as unnatural. And the thing is here that what is actually proof is that science does not choose the truth. They are choosing, should we say, the best explanations without complicating stuff. And that process is not objective. It's entirely subjective. One of the key problems here is actually, if we go back to the Silurian hypothesis, is that we have the assumption that a technological advanced civilization in the past is following the same development as we do today. So, because we have developed plastic, then they are also, okay, they need plastic. And so on it goes. And that is actually one of my key problems here. Imagine that you have um, a civilization that is actually, not created about burning fuel like oil and so on, but is more environmental. I don't know, they're using windmill or something else. The thing is that the energy consumption is not the same profile as we do today. They might use less energy. I mean, one of the key things is that transportation, for instance, nowadays, everything is transported. So if you have vegetables and so on, they can easily, if you live in US, they can easily come from Canada or Mexico, or perhaps even further away. That kind of things requires burning of fossil fuels. But the thing is that what if you choose to create the vegetables locally? Do your own gardening, for instance. That is an entire different profile, but it's also something that you will not find in the fossil layers. The thing is that they will probably be a stealth civilization in terms of what we are looking for, because we are looking for a civilization in the past that is doing the same as we are doing. They are not recognizing that things could be different. We could have a different development path. One of the key things is that if you look in the past, when the Soviet Union was existing, a lot of the fighters that they were using was actually based on different technologies that the West was using. In the West, we were using a lot of transistors, electronics, etc., where the Soviet Union was using different technologies based on old analog technology. That is not the same as it's not efficient, it's just a different path. So in the West, we were using microchips, etc., and in the past, they were using a technology based on old technology stuff with this radio based with analog stuff and so on, but it was working and it was efficient. And that is the key thing. It might not be the same as we doing, but if it fulfilled the requirement, then it's actually quite good. Furthermore, this kind of things is not, it's next to impossible to hack this kind of things. And if it's running, it will run forever. Where if you have electronics nowadays, they are a lot more fragile. So what I'm saying here is actually just because our civilization is based on carbon, it's based on burning of fossil energy, and it's heavy in terms of materials, especially rare materials and pollution, etc. But that's not the only way. There could be other ways. And because of that, you can have stealth civilizations, simply because it's using a different, should we say, profile. We are looking for our own profile. We do not recognize that it could be different. So my point here is that advanced does not mean visible. So we assume that the more advanced it is, the larger the fingerprint will be in terms of our fingerprints. But it could be a more sustainable civilization. Imagine that in the US you have the Indians. If their way of living was the victory, then perhaps we will have an entirely different civilization today. It will probably be more in, should we say, sustainable and all these kind of things. The bottom line is that after 50 million years or more, they will probably have a different, should we say, layer in the sediment than the one we have today. The assumption of the scientist is, because we have a global civilization, they must use energy in large scale. And they must do all kind of pollutions and etc. and so on. So the global signature will be the same as ours. So my point here is that we do not know what we don't know. And therefore we cannot be certain that we will recognize a previous civilization, even if its tracks is there. So my point is that you will never find a smoking gun. So because of that, it's not certain that you will detect a previous civilization. The assumption is today that an advanced civilization will control energy, and energy will always have a physical consequence. And that I'm not sure about. Thank you for listening.